Mr. Wright here, and welcome to this run-through of this Edexcel Maths IGCSE paper from November 20. If you'd like to download a copy of the question paper, then you will find a link in the description. Hit the link, download the paper, and you can have a good go at the paper before watching the run-throughs. This run-through is in two parts, so there are two films. The first film for the first set of questions and the second film for the rest of the paper. And at the end of the second film, you'll find a short film of me letting you know what the grade boundaries were for this set of papers to enable you to work out what your grade would have been had you sat these papers. If you find this film useful, please do hit like, give me some positive feedback. If you've got any questions, do leave them in the comments, and of course I'll respond. And if you are preparing for your Edexcel IGCSE Maths exam, you might do well to subscribe to the channel. Right, good luck with the paper. Question 11. Okay, we're entering into the second half of the paper now. We've had 47 marks already. Right, so we've got something to the power of 2/3. So what that's going to mean is that I have my something, and I'm going to find its cube root, and then I'm going to square that. Now the cube root of 8 is 2, and the cube root of e to the power of 15 is e to the power of 5, and I need to square that. So that's going to give me 2e to the 5 times 2e to the 5 is 4e to the power of 10. Okay, express this in the form a y to the n, where a and n are integers. Well, let's have a look. So first of all, let's dispense with that minus sign. So y over 2 to the minus 4 is 2 over y to the power of 4. Now 2 over y is 2 times y to the power of minus 1. And we've got that to the power of 4. So that's going to give me 2, 4, 8, 16. That's 2 to the power of 4. And then y to the power of minus 4, because I add the indices when I multiply. And that is my answer in the form a y to the n, where a and n are both integers. Let's look at part C. Now in this question here, I think I'm going to subtract these two fractions on the left and leave 6 on the right. Now, what shall I write them both as? They're thirds and quarters, so I'm going to write them both as twelfths. Now, if I'm going to write this first fraction, this fraction is twelfths, and I'm going to multiply top and bottom by 4, so that's going to give me 4 lots of the top. And the bottom to be multiplied by 4 to get me the 12. Write this equals sign, be careful with your signs. Now, this fraction here, if I'm writing it as twelfths, I've multiplied the bottom by 3, so I multiply the top by 3. And that all equals 6. Right, let's multiply both sides by 12. 6 12s is 72. And let's multiply out these brackets. So that's going to be 16x minus 8 minus 15 plus 9x. So on the left, I've got 25x minus 23. And on the right, I've got 72. Let's add 23 to both sides, gives me 95 on the right and 25x on the left. Divide both sides by 25, gives me 95 over 25. And I could use my calculator, of course, to cancel that down. 95 divided by 25 is 19 over 5. And that is my answer to part C. And that is question 11 complete. Question 12. Right, I've got this expression on the left-hand side, and I think what I'm going to do is I'm going to write it all in base 3, because I've got the 3 to the x, that's in base 3. And if I write this 9 to the power of 3x in base 3, then I think things will work out. Let's have a look. So, 3 to the power of x is 3 to the power of x. 9 to the power of 3x is 3, half the base, double the power. 3 to the power of 6x equals 81. So now, 3 over 3 to the power of x divided by 3 to the power of 6x equals 81. Well, if I subtract the indices, then I just get 3 to the power of minus 5x. Now, I wish this 81 was written in the base 3 as well. And of course it can be, because 81 is 9 times 9, which is 3 times 3 times 3 times 3. So 81 is 3 to the power 4. So this boils down to minus 5x equals 4, which means that x must equal minus 4 over 5, or minus 0.8. And that is question 12 done. Question 13. Right, use algebra to show that this is true. Okay, so I'm going to write x equals, and I'll leave a bit of a gap, as you probably learned, so that I've got some space. There you go, 0.68181881, and so on. Now I'm going to multiply that by 100, which will give me, if I copy my decimal point down carefully there, move everything up 2 place 68, and then I've got 1818118, and so on. And then I'm going to subtract my left-hand sides and subtract my right-hand sides. Why am I doing this? Because the 8, 1, 8, 1, 8 are all going to knock each other off. So I've simply got 68.1 minus 0.6, which is 67.5. Divide both sides by 99. 67.5 over 99. Well, that equals, if I multiply top and bottom by 10, that... Now, I know I'm looking for the answer 15 over 22. The truth of the matter is, if I put that in my calculator, it equals 15 over 22. So I know I've got it right, but it might be an idea to show how I've gone from 675 to 900. Clearly, I don't just want to say I put it in my calculator. You could do, I suppose, but I'm going to say that I have divided by 45. And I worked out the 45 just by working out how many 15s there were in 675 with my calculator. So that's question 13 complete. Question 14. All right, so it looks like we're looking at Venn diagrams here. So we've got a universal set with all the numbers from 10 to 25 inclusive in it. We've got A with all of the numbers in the universal set which are less than 18. So all the way up here, 15, 16, 17, but not 18. Then we've got B with all the integers from 13, including 13. 15, 16, 17, 18, 19, 20, 21, but not 22. Okay. Write down the number of elements in A. 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 elements in A. List the members in the set not A union B. Okay, well, let's think about what is in A union B to start with, in A or B. Well, anything from 10 to 17 is in A, and then 18, 19, 20, 21 are in B. So anything from 10 to 21 is in A union B. So not A union B is simply going to be the rest. So that's going to be 22, 23, 24, and 25. Now, list the members of the set. They've got to be not in A, and they've also got to be in B. Well, let's start off by thinking what's not in A. Well, not in A is 18, 19, 20, 21, 22, 23, 24, and 25. And they also have to be in B. So which of these are in B? 18, 19, 20, and 21. So the members of A, not A, intersection B is 18, 19, 20, and 21. Now let's have a look at D here. We've got C is a subset of A, and C is a subset of B, and there are 5 elements in C. So it's got to be 5 elements which are in A and in B. So it's going to be 13, 14, 15, 16, 17. There you go. 13, 14, 15, 16, and 17. That's the end of question 14. Question 15. Make x the subject. Right, well, I'm going to start by multiplying both sides by x plus 3. That's going to give me y times x plus 3 here, and 5 minus 2x there. Multiply out the bracket. Y times x plus 3 times y equals 5 minus 2x. Now I have to make x the subject. So I'm going to put everything with an x in it on the left and everything else on the right. So I'm going to add 2x to both sides to get rid of that minus 2x. So that's going to give me yx plus 3y plus 2x equals 5. And now I'm going to minus 3y from both sides to get rid of that 3y from the left. Gives me yx plus 2x equals 5 minus 3y. Right, now I'm going to fad this. I'm going to factorize and divide. Look at the left-hand side. Let's make x, take x out, y plus 2 equals 5 minus 3y. And now I'm going to factorize and divide by x plus 2. Y equals 5 minus 3x over x plus 2. And that is question 15 done. Question 16. Solve these simultaneous equations. Right, let's have a look at this. Now I've got these, one of these is quadratic, so I'm probably going to use my take from one equation and substitute into the other equation method. Now look at this. From this equation, I can see that x will be 1 plus 2y. So I'm going to take 1 plus 2y and substitute it into the second equation for x. So the second equation is this. And now I'm going to substitute in 1 plus 2y instead of x. So I'm going to end up with 3y multiplied by 1 plus 2y minus y squared equals 8. That gives me, multiply out the bracket, 3y plus 6y squared minus a y squared equals 8. So 5y squared plus 3y, let's set it equal to 0. There we go. So how am I going to find y now? Well, I'm going to factorize that. See if it factorizes. There's going to be a limited number of options because I've got to have 5y and y to get my 5y squared. Now for my 8, I suppose it could be 1 and 8. Actually, I quite like that. Look, because I could have the 8 here and the 1 here. I know one of them's got to be minus and one of them's got to be plus. If I make that a plus, then I get plus 8y and then minus 5y, and that'll give me plus 3y. So I've managed to factorize it, and now I can write down my two solutions for y. Y will be 1 or minus 8 fifths. And each of those solutions for y will give me a solution for x. I know, look at this, that x is 1 plus 2y. So if y is 1, then x is 1 plus 2 is 3. And if y is minus 8 fifths, then x is 1 minus 16 fifths, which is minus 11 fifths. So there are my two sets of solutions. And remember, you need to make it clear that each set is a sort of pair. So I'm going to write 3, 1, and minus 11 over 5, minus 8 over 5, to make it clear that I haven't got 4 solutions, I've got 2 solutions, each one is a pair. And that's question 16 done. Question 17. Okay, I've got a rectangle, and it tells me that the area of the rectangle is a square centimetres. Given that a is less than 3x plus 27, find the range of possible values for x. Now be careful. At the end, I'm going to need to come back to the context of the question to find the range of possible values for x. Because, for instance, we wouldn't want to suggest that the length of one of these sides was negative, for example. So let's remember to come back to the context. Now the area of the rectangle is 2x minus 4 multiplied by 3x plus 2. So I can simplify that or expand the bracket. 6x squared minus 12x from the middle plus 4x is minus 8x minus 8. So that is a, and I'm told that a, which is 6x squared minus 8x minus 8, must be less than 3x plus 27. Right, set that equal to 0. So I'm going to have 6x squared minus 11x minus 35 is less than 0. Right, okay, this is going to put my factorising to the test. I see it says find the range of possible values for x. I suspect that x is going to be whole number values, or at least easy fractional values. I don't think I'm going to be using the formula here. So let's try with 2x and 3x. Of course, it could be 6x and 1x, couldn't it? 7 and 5 is bound to be 7 and 5. I'm going to try 7 and 5. Now, one of these is plus, one of them is minus. Can I end up with minus 11 x's? Well, if I do minus 7 times 3, that's minus 21, and plus 5 times 2x is plus 10. There you go, minus 11, as luck would have it. Okay, so what are my solutions here? Well, this one gives me x is equal to 7 over 2, or 3.5. And this one gives me x is equal to minus 5 over 3. So if I just ignore the context of the rectangle for a moment, given that I've got a positive x squared here, my function is going to have values of less than 0 when x lies between minus 5/3 and 3.5. Okay, now let's just go up and have a look at this rectangle. If I look at the length of the rectangle is 2x minus 4. Well, clearly that rectangle has to have a positive length. Now that rectangle is only going to have a positive length if x is greater than 2. So now I'm thinking that 2 has to be less than x, has to be less than 3.5, because there's no way x can be less than 2 anyway. And that has brought us back to the context of the question, and that is my answer of the range of possible values for x. X can lie between 2 and 3.5. And that is question 17, done and dusted. Question 18. I've got a cuboid here, and I'm given a couple of side lengths which are already drawn on the diagram. And then I'm told that the size of the angle between CH, well here's CH, the size of the angle between CH and the plane ABCD, well the plane ABCD is the base. So the size of the angle between AHC, or CH, and the base is going to be this angle as marked, with AC being the diagonal across the base of the cuboid. That angle apparently is 35. Okay, and I'm asked to find the volume of the cuboid. Now to find the volume, I'm going to have to do 4 times 5, the length times the height, times BC, aren't I? BC, the width there. So really, this is a question about finding that length, the length BC. Now, I see that BC is part of a right angle triangle on the bottom of the cuboid. It's part of this triangle, isn't it? It's part of the triangle from A to B to C. Let's just draw that triangle. Yeah, A, B, C. And I know that that's 5. I know that's a right angle because this is on the base of the cuboid, and that's a right angle at B. And I don't know AC, which is a bit annoying, because if I did know AC, then I could find BC using Pythagoras, couldn't I? Now, however, if you have a look at triangle H down to A, and then A across to C, and then up again here, let's have a look at this triangle. So that's the triangle H, A, C. Now I know that that's 35 because it tells me in the question, and I know that's 4, HA. Now I can use this triangle to find the length of AC. Look, because if I call AC X here, I can use tan, and I'm trying to find the adjacent. So the adjacent X is the opposite 4 divided by tan the angle. So now I've found the length of x. It's actually 5.71, but keep the whole number on your calculator. So x is 5.71. Right, so AC is 5.71. So that means, go back to this triangle, AC is 5.71. I know that AB is 5, so I can find the height of the cuboid, BC, so it's not the height of the cuboid, it's the width of the cuboid, using Pythagoras. So that means that CB is going to be the square root of 5.71 squared, but use the whole number, subtract 5 squared. So that means that CB is equal to the square root of 7.6, and so on and so on. Keep the whole number on your calculator. So the volume is equal to 4 times 5 times the length of CB. So square root that whole number on your calculator, multiply it by 4, multiply it by 5, gives me an answer of 55.258, and so on, which to three significant figures is 55.3. 55.3 cubic centimetres to three significant figures. Question 19. Okay, vectors. OAB is a triangle. Right, let's draw OAB. So let's have O to A, maybe like that. And then let's have O to B, maybe like that. O, A, B. So it's a triangle. So let's complete the triangle. There we go. All right, and it tells me that O to A, that's the vector A. O to B, that's the vector B. Right. The point C lies on OA such that OC to CA is 1 to 2. Right, so OC to CA is 1 to 2. So it cuts it in that ratio there. The point D lies on OB such that OD to DB is 1 to 2. That's going to cut it in a similar ratio, isn't it? In the same ratio, 1 to 2. Okay. Using a vector method, prove that what? A, B, D, C, so prove that this shape is a trapezium. Of course, I probably should have labelled my D and C. There you go. I've got to prove that shape is a trapezium. Well, what this is really asking me to do is to prove that the vector AB is a multiple of the vector CD, i.e. prove that AB and CD are parallel. So we're going to find the vector CD, and we're going to find the vector AB, and we're going to see if one of them is a multiple of the other, in which case the two vectors, the two lines are parallel. So to go from C to D, I would have to go from C backwards along A, so minus a third of A, isn't it? Now I'm at O, and I would plus a third of B. Okay, so let's just simplify that. Let's take out the third, shall we? Leaves me with B minus A, a third of B minus A. Right, if AB similarly is a multiple of B minus A, then we're on a winner. So if I went from A to B, to go from A to B, I would go minus the vector of A plus the vector of B. And that is just B minus A. Haha, that's 1, if you like. That's 1. A lot of B minus A. So look at that. The vectors CD and AB is a multiple of CD, isn't it? I mean, AB happens to be 3 times CD. It doesn't matter what multiple of CD it is, but it is a multiple of CD. Therefore, A, B, and CD are parallel. Therefore, A, B, D, C is a trapezium. And there we go. That was using a vector method. Where's it gone? using a vector method to prove that ABDC is a trapezium. Question 20. Right. A bag contains X counters, only red and blue counters in the bag. There are 4 more blue than red. So if there are red, then there would be R plus 4 blue. And altogether, there would be 2R plus 4 counters in the bag. All right. Finty takes at random 2 counters from the bag. The probability that he takes 2 blue counters is 3/8. So I'm going to set up an equation here. Let's have a look. Can you imagine the probability tree? When he takes his first counter, it's either going to be blue or red. And then he takes the second counter. It's either going to be blue or red. There we are, blue or red. Now, the probability of taking 2 blue counters, so this probability here, that equals 3/8. So I can find this probability and this probability, multiply them together. That's going to give me an equation because those two multiplied together equals 3/8. Then I could find R, and therefore I could find X, the total number of counters in the bag, because that's what I'm being asked for here. So let's start here. What's the probability of getting a blue, first of all? Well, that's going to be R plus 4 over the total number of counters in the bag, 2R plus 4. Good. Then, having got a blue, what's the probability of getting another blue? Well, there'll only be R plus 3 blues left in the bag after that first one's gone, and there won't be 2R plus 4 counters in total, there'll be 2R plus 3. So it's those two fractions multiplied together that equals 3/8. So I best solve that equation to find out what R is. Right, I know how to multiply fractions. Top times top, bottom times bottom. R plus 4 multiplied by R plus 3. R squared plus 7R plus 12. Bottom times bottom. 2R plus 4 multiplied by 2R plus 3. 4R squared plus 8R's from the middle plus another 6. 14R plus 12. And I know that equals 3/8. Let's multiply both sides by 8 to get rid of the 8 on the bottom on the right, and also multiply both sides by 4R squared plus 14R plus 12 to get rid of the 4R squared plus 14R plus 12 from the bottom on the left. So I'm going to end up with 8 lots of R squared plus 7R plus 12, and that's going to equal 3 lots of 4R squared plus 14R plus 12. Right. Multiply out the bracket. 8R squared plus 56R plus 96 equals 12R squared plus 42R plus 36. Okay, quadratic equation, set it equal to 0 and factorise. So let's put 0 here. Minus 8R from both sides. Minus 56R from both sides. Minus 96 from both sides. Okay. Let's divide both sides by 2, make it a bit easier. Shame we can't divide by 4. Divide by 2, 2R squared minus 7R minus 30 equals 0. Got to factorise this now. Let's have a look. Well, obviously it's going to be 2R in one bracket and 1R in the other. Now 6 5s are 30. If I had 6 2s are 12. If I did minus 12 and then plus 5 of the R's, that's going to give me minus 7R. So there we go. So that's going to mean that either R is minus 5 over 2. Well, that's ridiculous because you can't have a negative number of red counters, so it's not going to be that. Or R is 6. Clearly R is 6. Let's go to the question. It says to me, work out the value of X, the total number of counters in the bag. Well, the total number of counters in the bag is 2R plus 4. So that's 2 times 6, 12 plus 4. So that's 16. And that is the end of question 20. Question 21. Right, here we go. A function f is such that f of x equals that, for x is greater than 3. We mustn't forget that. Right, part A. Express 5 plus 6x minus x squared in the form p minus x minus q squared. We're completing the square, aren't we? Here we go. So we've got 5 plus 6x minus x squared. I'd like to write that x squared as a positive, really. I'm going to write 5 minus, and that means I'm going to have x squared minus 6x. Good. Now I'm going to complete the square on the square bracket. 5 minus. I'm going to write x minus 3 squared, and from that I'm going to have to subtract 3 squared, 9. Okay, let's take that minus 9 out of the negative bracket. So that's going to become a plus 9 now, isn't it? So that's going to be 15. So that's going to be 5 plus 9, which is 14 minus x minus 3 squared. And that is my function here, expressed in the form p minus x minus q squared. Good. Using your answer to part A, there's a bit of a clue. Find the range of values for which the inverse function of x is positive. Okay, well, we know already that our function of x equals 14 minus x minus 3 squared. So I'm going to find the inverse function now. So there's kind of standard method for doing this. Y equals 14 minus x minus 3 squared. Make x the subject of that. So it's going to be y minus 14 equals minus x minus 3 squared. So let's change the signs. So that's going to give me, I'm going to write it the other way around as well, just to confuse you. So that's x minus 3 squared equals 14 minus y. Okay, now I need to square root 14 minus y and then add 3. So x is going to be 3 plus or minus, because of course there are 2 square roots, of 14 minus y. Okay, looking good so far. Now, I'm told that x is less than 3. If x is less than 3, or less than or equal to 3, then I can't possibly have values here that are more than 3. So actually, the inverse function of x must be 3 minus that square root. Otherwise, I could have values of x which were greater than 3. Okay, so there is the inverse function of x. And I've got to find the range of values for which this is positive. So I'm going to be looking at this, aren't I? 3 minus 14 minus x, 3 minus root 14 minus x has got to be greater than 0. Okay, so minus the square root of 14 minus x has got to be greater than minus 3. Multiply both sides by minus 1, and remember to change the inequality sign. There we go. Square both sides. 14 minus x is less than 9. Okay, subtract. I'm going to add x to both sides and subtract 9. There we go. So 5 is less than x, or x is greater than 5. So 5 is the lowest x can be, isn't it? Okay. It's fine. And how high can x be? Because remember, I'm asked to find the range of values for which the inverse function is positive. Now, x could be anything from 5. How high can it go? Well, here's the inverse function. All right, and clearly I can't have a square root of a negative number. So x can only go as high as 14. So my range of values for x, for which the inverse function is positive, is that x must be greater than 5. Sorry, x must be greater than 5. So 5 is less than x, is less than or equal to 14. And that's quite a tricky 5 marks for the last question, last part of the last question of the paper. All right, that's the end of it. End of question 21. Mr. Wright here, and well done for making it through to the end of the paper. In a moment, I'll show you the grade boundaries, and I'll show you how to calculate what grade you would have got had you been sitting this paper or this set of papers. But first, if you found these video walkthroughs useful, please do hit like. It really helps the channel, and it tells me that you have found the film useful, and it's good to have some positive feedback. Of course, if you want to see more of the same, do subscribe to the channel, and then you'll get notifications every time I post something new. So, the grade boundaries. Well, here they are. And what you need to do is to add together your 2 marks on the 2 papers. Of course, both marks out of 100, so that gives you a total out of 200. And then you can use this table to read off what your grade would have been had you sat this set of papers. Leave me a comment, tell me how you've done, and good luck with your exams.